class today, we are given a question on relationship in trigonometry. Relationship in trigonometry. So what are the relationships we have in trigonometry? These are called the SOH CAH TOA. The SOH CAH TOA. Let's go to the question. In the question we are given that if tan theta equals 2/3, then sec square theta equals what? Now the way to solve this is actually simple. Since we are given that our tan theta is equal to 2/3, and recall that tan theta is known to be what? TOA. So that means our opposite is 2, then our adjacent is 3. So my opposite here is 2, and my adjacent here is 3. And when I try to represent this on the right angle triangle, making use of a right angle triangle, I'm going to have my perpendicular angle, and also I'm going to have my curved angle indicating the theta. From the question given to us, we have that our opposite is 2. So this is where we have our opposite, and that's 2. And we have our adjacent to be 3. This is where we have our adjacent, and that's 3. But we're not given the hypotenuse, which is at this side. And we have to find the sec square theta. Recall that sec theta itself is the inverse of cos theta. And for us to get the inverse of cos theta has the relationship that says adjacent over hypotenuse. So it means that if I don't know my hypotenuse, I can't solve for my cos theta, and I can't get my sec theta, and I can't get my sec square theta. So that means we need to know the value of our hypotenuse. So how can we get the value of our hypotenuse? A quick one. Using Pythagoras, when I try to make it a Pythagoras theorem, I'm going to have that a square, which is my hypotenuse, equals to 2 square, which is my opposite, then 3 square. So I have here as a square equals to 2 square give me 4, then 3 square give me 9. So that means my a square equals to 4 plus 9 will give me 13. On the long run, I will find the square root of both sides. When I square root the both sides, the square root cancels out the square. Then I'm left with that the value of my h should be the square root of 13. Now that I'm considering that our hypotenuse is square root of 13, it's very easy to get the value of my cos theta first. Because the question is to find sec square theta, and sec square theta is the inverse of cos square theta. So for me to get my cos square theta, let's see how we can get our cos theta. Our cos theta is adjacent over hypotenuse. Now you look at it carefully, we have that our adjacent was 3. Adjacent was 3. Now our hypotenuse was root of 13. So for me to get my sec square theta, I'm going to have that sec square theta is now equal to 1 over cos square theta. And the value of my cos theta is this. So in putting this into the equation we have, I'm going to have 1 all over the square of 3 all over square root of 13, then in the power of 2. Why? Because we already have here a square, so the square must be put in here. The square must be placed here. So note something, that the square here is for both the 3 and also meant for the root of 13. So I can write this as 1 all over 3 square all over, not all over, yeah, all over the square root of 13 all square. So the square root can cancel out the square. I'm going to be left with 1 all over 3 square will give us 9. That means I'm going to add it as 9 all over 13. So in the long run, the inverse will be 13/9. So this is the value of our sec square theta. Now let's look at the option whether we have such an answer. Coming down to our option, the right answer is option B. Option B stands as the right answer.